All right. So welcome to discussion section 11 for math 32. Okay. All right. So today we're going to go over some of the quiz questions that you guys did. So video quiz 8, question 1, question 7, question 9, and then question 3 and question 5 from video quiz 9. Okay. So first question is, how many live polls, pop-up quizzes did we do during lectures for the week of March 29 to April 2, 2021? How many questions for each poll pop-up quiz? So this was the question asked, the first question asked in video quiz 8. And if you guys attended the lecture or at least watched the recordings, you guys would have known what the answer to this was. As we all know, the lecture attendance in this course isn't mandatory, but if you miss a lecture, you should definitely watch its recording as soon as you can. And then Li Hong mentions here that math is learned by doing and by actually spending your own time solving the problems, understanding the solutions. So there is no way around this, okay? Any questions about this one? Okay. No questions, so I'm going to move forward to video quiz 8, question 7. So we are given that x and y are independent. Remember this, independent. If we are given that probability of x equals to 0 equals to probability of x equal to 1 and probability of x equal to 2, which is equal to 1/3, and then probability of y equals to 1 is also 1/3, the probability y equals to 2 is 2/3. What is the variance of z, which is another variable, which is defined as the sum of the previous two? Okay, so if we look at this, we have done these kind of questions in lecture 26, so the first video in the video list 8. Okay, so if you look, we have z right here as x plus y. Okay, and then if we look at this question, we have probability for these values of x, and then we have probabilities for these values of y. So if you have to tell me what are the possible values that x can take and what are the possible values that y can take, what would you tell me? Not the probabilities, but the actual values that x and y can take. What would you tell me? Anyone? You can type it up in the chat if you want. Anyone? Remember participation points? Oh, cool. Thanks, Ahmed. Thanks, Amrita. Yes, 0, 1, 2, and 1, 2. Perfect. So x can take 0, 1, 2, and y can take 1 and 2. Is that clear? So if we go down here, we made a table where z is the sum of x and y. X can take 0, 1, and 2, whereas y can take only 1 and 2. So since we are summing x and y, so the first entry here is just x equals to 0 plus y equals to 1, which is just 1, x1, y1, which is 2, and we go so on. Now, these values in this table are the values that z can take, okay, because z is the sum of x and y. So z can only take 1, 2, 3, or 4, right? So because this is 2, 3 is occurring twice as well. Okay, so now that we have this table, we know what values z can take. Now, how can z get to those values? So that means that we need to first find probability of z equal to 1, z equal to 2, z equal to 3, and z equal to 4, because z can take 1, 2, 3, and 4, right? Okay, so now, when can z be 1? If we look at this table right here, when can z be 1? I'll give you this time, and then next time you guys would tell me. Z can become 1 when X is 0 and Y is 1. That's the only possibility, because that's the only that's the only time 1 is occurring in the Z values. Okay, and since these variables are independent, we can just multiply their probabilities. So we can take probability of X equals to 0, because that's when what would happen, times probability of Y equals to 1. So if you multiply those two, which are given to us above, we get 1/9. So probability when Z equals to 1 is 1/9. Now we have to find when Z has to be 2. There are 2 places. So what should we do? What are the 2 possible X and Y's when Z can be 2? Anyone? X1, Y2, X2, Y1. You're almost there. Ariana, yes. X1, Y1. That's one of the possibility. Good job. Then Ahmed, yes. Taija, you said X1, Y2. You're also almost there. Ahmed, yes. X1, Y1, X0, Y2. So if you look at this table, when is this 2 occurring? This 2 is occurring when X is 1, Y is 1. And then we have another 2. This is occurring when X is 0, Y is 2. Okay? So what we'll do is probability of X equals to 0 times probability of Y equals to 2 plus probability of X equals to 1 and Y equals to 1. And what is probability of X equals to 0? It was 1/3. Probability of Y equals to 2 was 2/3. So we'll multiply those. We'll add 1/3 times 1/3. That's given to us. So this is 2/9 plus 3/9. Okay. Oh, sorry, 1/9. I'm wrong here. 1/9, so this is 3/9. That's how big it is. Does that make sense? Any questions so far? Yeah, Taija got it. Yes. Okay. Any questions so far? Okay. Makes sense. Cool. All right, I'm reading the chat on the side. Okay. So now let's find the Z equal to 3. So now Z is 3 at these 2 places. So one is when X equals to 2 and Y equals to 1. And the other is when X is 1 and Y is 2. So we'll take these, probability of X equals to 1 times probability of Y equals to 2 plus probability of X equals to 2 times probability of Y equals to 1, and we again get this thing. Okay? And then for 4, there's only one possibility when X is 2 and Y is 2. So we'll just multiply those 2 probabilities and we get 2/9. So we have 1/9, 3/9, 3/9, 2/9. Okay? All right. What was our question again? We had to find what is the variance. Now we found all these probabilities. Now you can also check if you did it correctly or not by adding all these probabilities, and they all need to add up to 1, right? The PMFs. Okay, now that we have the probabilities, just restating it here. Now we know we can find the variance of Z by this common formula. The variance of Z is expected value of Z squared minus the square of the expected value. Now, how would we find the expected value of Z? Just Z times the probabilities, right? So in this case, Z is going from 1 to 4, as we already found. Z can only take 1, 2, 3, and 4. So Z is going from 1 to 4. Z times the probability of Z. So this will be when Z is 1, we'll have 1 times probability when Z is 1 plus 2 probability when Z is 2, 3 times probability when Z is 3 plus 4 times probability when Z is 4. So this will be 1 times, what is the probability of Z equal to 1? We found it right here, 1 over 9, or it's also mentioned here. So 1 times 1 over 9 plus 2 times 3 over 9 plus 3 times 3 over 9 plus 4 times 2 over 9. When we add all these up, we get 8/3. Is this clear? Should choose probably a different color for this. Right. Does that make sense? Everyone clear? You add this value, this value, this value, and this value to get 8/3. Yeah, cool. Similarly, you can find the expected value of Z square. Again, Z is going from 1 to 4, but now instead of Z, we have Z square. But the rest of the things will stay the same, but now it will be, so if we have Z equals to 1, so it will be 1 times the probability when Z equals to 1, which is 1/9, plus, this is for this purple one, 2 squared. So 2 squared is 4, so I'm just going to write 4 here. 4 times 3 over 9 plus 3 squared, which is 9, times, again, 3 over 9, plus 4 squared, 16, times 2 over 9. And then if you add that up, you will get, let me pick a better color, you will get 8. Okay, so what I added was these, and this. Okay, and that's how you will get this 8. Is that clear? Any questions so far? No? Okay. So now the last part is, of course, to find the variance of Z, which is just expected value of Z square minus the square of the expected value of Z. So expected value of Z square we found as 8. So 8 minus the square of 8/3. If you do that, you get 8/9, and that is your answer right here. Okay? Any questions? No questions? Can I go up a slide? Absolutely, I can go up a slide right here.
One more. Can you go
right here?
Oh, wait, no, I think it might be that other one.
Which one? This one?
Yeah, yeah.
Okay. But by the way, does that help? Like me doing it on the iPad, does that help than usual? Yeah? Okay. Perfect. Perfect, perfect. Okay. Good? Amrita, are you good? Yes? Okay. Yeah? Yeah, Luis, me too. I learned that recently and I was like, yes, we can do that. Okay. There is another method to go, to do this question. Would you guys want to do it? Do you guys want to see the next method? Yes, no, maybe? Yeah? Yeah? Okay, I've got you, yes. Okay. So method 2 is that remember that when we add two variables, their variance is variance of X plus variance of Y plus 2 times the covariance of X and Y. But in this case, we know that our x and y are independent since it's given to us in the question. So when those two variables are independent, then their covariance is 0. Okay, so we need to know this before we do the second method. Now, variance of x and y is this, but in this case, since this goes to 0, so it should just be the sum of these two. Okay? Okay, I don't want to have too many annotations. No. But this goes to 0, and it will be sum of these. Okay. All right. So we know x can be 0, 1, and 2, and we know the probabilities that are given to us. Now, what would be the probability, these probabilities, if we multiply by x? So we multiply x. So what we are trying to do is, since variance of x plus y is variance of x plus variance of y, now we are trying to find these variances. So we are trying to find variance of x and variance of y separately, so we'll add them up later. Okay, so since we know the values of x, 0, 1, and 2, and we also know these probabilities that are given to us in the questions. So now if you multiply x to these probabilities, so we'll get 0 times 1/3, 0. 1 times 1/3, 1/3. 2 times 1/3 is 2/3. And if we multiply by x squared, we'll get 0. Sorry. So x squared is 0 squared is 0 times this probability 1/3, it's still 0. 1 squared is 1. So 1 times 1/3 is still 1/3. But 2 squared is 4. So 4 times 1/3 is 4/3. Okay. Now we know variance of x is just expected value of x squared minus the square of expected value of x. So if we add, okay, let me actually annotate this. If we add these values, so 0 plus 1/3 plus 4/3, this is our expected value of x squared because we're multiplying by x squared here. But if we, this one, if we add these values, let me do that right here. So 0 plus 1/3 plus 2/3, this is the expected value of x. So we took expected value of x squared, which is the sum of these three, so it's like 5/3, minus we take the sum of this, which is the expected value of x, it's like 3/3, or which is 1, so 1 squared because it's squared, so we get 2/3 right here. So we found the variance of x. Okay. All right. Now we have to find the variance of y the same way, but the y can only take 1 and 2. And we are given with the probabilities of these. So we just multiply y by this, and then we multiply y squared by this probabilities, and we get these. So again, if we sum these up, we'll get expected value of y. And if we sum these up, we'll get expected value of y squared. Okay, sorry. So this is 3, and this is 5/3. So we do 3 minus square of 5/3, we get 2/9. Now to find variance of z, what is z? X plus y. So we have to find the variance of x plus y, which in this case is just variance of x plus variance of y. So we take this variance of x, add it to variance of y. Now, why does variance of x plus variance of y? Because we already discussed that since x and y are independent, so covariance is 0. Is that clear? Any questions? Yeah, clear. Cool. Thanks. Let's move on to the next one now. So we again have two random variables which are independent. And the first variable x belongs to the exponential distribution with lambda greater than 0. And y belongs to the uniform distribution with 0 and 1. We have to find the CDF for z, which is the sum of these two. Yep, so let's see how we would do that. So here she mentions that the textbook only provides a formula for the PDF of the sum of two independent continuous random variables, but we provided a formula for the CDF in lecture 27. Okay. All right. So let's see how we would do this. So since X and Y are independent, what are we going to do is we have X plus Y. We can say that's because that's how we find the CDF. That's the definition of CDF. So Fx of little x should be probability of x less than little x, right? But in this case, since we are finding it for z, and z is x plus y, so we'll have probability of x plus y less than equal to this little z. Now, since we have two variables, we have this double integral, and the double integral of x plus y less than z, and we are integrating this function, the joint PDF of xy, right? All right, so since these are independent, x and y independent, then that means this joint PDF is just the product of these individual marginals. Is that correct? Kajal, what problem are you referring to? The one we just did, or what one I am doing right now? Sorry, I'm just trying to read the chat. The one we just did, this one. Was that set up in the this one?
No, you could go down some more. Keep going, keep going. Right here, this problem.
This is the same problem as this one.
Oh, okay.
It's just different method. Okay?
Okay.
Okay. So let's get back to this problem. Okay. Since in this problem we are given that x and y are independent, then the joint PDF should be equal to the product of its marginals. That means we know that x plus y is less than or equal to z. So we can integrate y from negative infinity to z minus x. You can actually do it other way around as well, but that's fine. And then if you see this integral is particularly because it's going to z minus x, it's just the CDF of y, z minus x, and then we have the marginal of x still being multiplied, okay? So this is just a derivation if you just don't want to memorize it. Okay, so the key is to figure out the correct bounds to integrate. So we know that x belongs to the exponential distribution. The marginal of x is just a PDF of this, which is, we know, lambda times e to the negative lambda x. And the CDF of exponential distribution is 1 minus e to the negative lambda x. And we know this is true for when x belongs to 0 to infinity. Now, y belongs to the uniform distribution. And we know the marginal, or just a PDF of y would be 1, and the CDF is just y. When y is between 0 and 1, and from uniform, we are just given that here. Okay, so there are three cases now when z is less than 0, when z is between 0 and 1, and then when z is greater than 1. So let's go to these step by step. So since the smallest number, x and y can take from the joint to be is non-zero is 0, right? Has to be non-zero. Sorry, to be non-zero is 0. The smallest number can take to be non-zero is 0. Yeah. Okay. So when z is less than 0, right? So z is the sum of x plus y. Is that correct? Okay. So the joint PDF should be 0. So when z is less than 0, the smallest number it can take is 0. So if the product is or the joint is 0, then the CDF is also 0 for Z less than 0. Whereas the case 2, when Z is between 0 and 1. Okay, so note that you can take value large. Note that neither X nor Y can take value larger than Z. Okay, so we know X plus Y is less than equal to Z. So we multiply, since these are independent, we can multiply by their marginals. Okay, so Y is from 0 to Z minus X. And then X is from 0 to Z. Okay, so we'll do this part. We know what's the marginal for Y is just 1, as we found here. Here, marginal for Y is just 1. And if we integrate Y equal to 0 to Z minus X of 1 dy, what is it? Just Y, and then you do the bounds. So you will end up getting just Z minus X, whereas Fx is lambda e to the negative lambda x. Okay, so we'll just do some other calculations, and we are integrating this for x from 0 to z. If we do that integration, you will get something like this. Okay, or you can also do it the other way around. Here we took y in, but here we can also take x in and derive, integrate x first, and then we can integrate y. Doesn't matter how you do, you're gonna end up getting the same result. Okay, now case 3 is when z is greater than 1. We cannot given the value of 1. Okay, what do you mean by that? Can you explain me further? Can you elaborate on your question? What if you're not given the value of y? You mean the PDF of y? That's how we found it, right? So we knew the distribution y belongs to, right? We know it belongs to uniform distribution, and we know that when it belongs to uniform distribution from A to B, how to find its PDF and how to find its CDF. So if you want to look back on your notes from when you guys discussed the uniform distribution and its PDF and CDF, okay? All right. So case 3 is when z is greater than 1. So again, neither x nor y can take values larger than z. And the largest value y can take to be non-zero is 1. Okay, so again, the CDF on x plus y less than equal to z, again, it's a product of these two. Again, you can do x first, y first, doesn't really matter. When x is going from, well, in this case, it won't matter because z is greater than 1. Okay, x goes from 0 to z minus y is from 0 to 1. And then we know the marginal for x, and we also know the marginal for y. Just plug those in, integrate the double integral, and get this. Now to combine the whole thing, we have 0 for z less than 0, z plus this whole thing between 0 and 1, and z greater than 1, we have this. Okay, this is the CDF. How would we find the PDF? By just finding the derivative of it. If you find the derivative, you will get this. Okay. All right, any questions? No questions? Can I move forward? Ariana, I think it should be given. X belongs to exponential and y belongs to the uniform distribution. What if we are not given the y part? I think if they are trying to add or do something, it should be given. Okay? But we can talk more about it later. If you have a specific question, we can talk about that, okay? All right. The next question is, we roll a 6-sided die 360 times, and we denote X by the number of times that the up face is 4. Use Chebyshev's inequality to bound the probability that X is at most 40 or at least 80. Okay, enter your answer numerically and accurate to 3 decimal places. So if you have 1/3, you should do this. Okay. All right. So what kind of distribution does X follow by this question? What do you think? What kind of distribution does X follow here? Good, thanks, Ellen. Binomial. Okay, so this follows binomial distribution with the parameters 360 and 1/6. So this is the n number of times. This is the probability each for each success. Okay, and then how do we find the expected value for binomial distribution? Does anyone remember? This is n and this is p. Expected value or mean is just np, and variance is just this. Okay, but you can also look at in the lecture 11 or the 6th video in the video list 3 to get how to find these things. Okay. All right, now that we have defined these, we need to find, okay, so when it says use Chebyshev's inequality to bound the probability, that is, what probability are we finding? That X is at most 40 and or at least 60. Or always symbolizes union. So here you will see I have a union. Okay, at most 40 is I cannot go beyond 40. Or X cannot go greater than 80, at least 80. So at least 80, it can be greater than 80 or less than 40. Like what is the probability that either this happens or this happens, right? Now, if we look at Chebyshev's inequality, it is probability of y minus the expected value of y is greater than some amount, a. Then we use this inequality, okay? All right, and this y minus expected value of y is in the absolute values. Now we have to see how to make this in the format of Chebyshev, okay? We know y, so we have the variable x, so absolute value of x, I think I should write this down. Okay, I have absolute value of x minus expected value of x. So expected value of x is 60. So I need to see how to bound this, right? Okay, so if you know something about the absolute values, if this has to be greater than some number, let's see. This is x is less than equal to 40. How would we get to 60? If we just add 20, right? Or what we can say in other words is if we do x minus 20 is less than 40 minus 20, union x minus 20 is greater than 80 minus 20. Okay, and if we get through this inequality, you will see in the absolute terms, it is x, absolute value of x minus 60 is just greater than 20. Okay, so what I'm trying to say is that x minus, let's say b, when it's greater than some amount, I don't know, c, then we have x is less than something, or X is greater than something. And we have that pattern going here. So we found our A in this case is 20. And so if we can write this as this, then we can definitely choose or use this Chebyshev's inequality, which is 1 over a squared, and our a is 20. So 1 over 20 squared times the variance of y, or variance of x here is 50. And we do that. This is our answer. Okay. Does that make sense? Yeah. Got a few yeses. Okay. So let's move forward. Question 5 from video quiz 9. Okay. Yeah, this one's a little bit complicated one. So we have 100 independent and identically distributed random variables, x1 to x100. Each of these variables follow a Bernoulli distribution with parameter p as 0.1. Let y be the sum of all these. Then approximate the probability that y is greater than 30 using the central limit theorem. Okay. All right, so let's first review what the central limit theorem said. So the central limit theorem says that if we have x1, x2, and so on, any sequence of independent and identically distributed random variables with some expectation mu and finite variance as sigma squared, then for each integer n greater than 1, Zn should be this. Okay. Then for any number a, limit n goes to infinity, the CDF is just phi of a. Okay, and phi is the CDF for the standard normal distribution. Right? Okay, so if we look here, xi belong to Bernoulli, and we have the expected value of xi to be 0.1. And if the expected value is this, we know the variance for Bernoulli should be 0.09. Okay. And we define y as the sum of these variables. And since they're independent, we can just write it as nxn, the sum of all these, with n equals to 100. Okay, sorry, n xn bar, that is the total sum, as the mean of the total sum is n times the mean of xn with n being 100. Because if you remember, we define the mean or the x bar as the sum. Let's say it's still 100, so till n divided by n, right? So in this case, since we have the sum, we just moved this n here. So n times xn bar is the sum of these. Make sense? Hopefully. Okay, so according to the central limit theorem, we have this that we define as z. So we want to calculate probability of y greater than 30. Now we just said y is nxn, right? So we have to find when nxn is greater than 30. Now to bring it to this form, we need to do some calculations. So how we usually bring it to the standard normal form is whatever variable we have, we subtract the expected value and we divide by the variance. In this case, our variable that we have is multiplied by n. So what we do is, to make it easier, we have nxn bar. So we subtract the n times the expected value. Usually we just subtract the expected value, but in this case, there is an n attached to our variable. So we just do nxn bar minus n, the expected value of xi, divided by the square root of n variance. So sigma is just square root of variance. So we can just say that. So divided by square root of n variance. But whatever we do on this side, we also have to do it on this side. So we have been doing nxn bar minus n expected value of x is, so we'll also do that same on 30 minus n expected value of x. And then we divide this whole thing by square root of n variance xi. We'll do the same thing over this side. Okay. Now, if you look that we can, so from here, there is a common n, so we can factor that out, and we'll be left with xn bar minus expected value of xi. And we divide that by square root of n times square root of variance, right? So if we simplify this n and this squared n, we just get this square root of n right here. Okay? Make sense? Just a simplification for this side. Why did we do that? This simplification? Because now this thing looks like Zn. So we can replace it by Zn. And here we can see that we already have n as 100. So we have 100 times expected value of x, which is 0.1, divided by square root of n variance. 100 times the variance is 0.09, and then we get this. Now, since we have this greater than, we just say this 1 minus less than, which is 1 minus less than phi of 20 over 3. Now, if you have the standard normal tables with you, you can definitely find the value of this phi and then subtract it from 1. But if you don't, you can just leave it as this. And I made a little mess, which I want to erase. But does it make sense? How do we get variance again? Wait, which one? I'm not sure which one. Oh, this. So when we have Bernoulli, so go back and refer to your notes. How do we find variance of x when x has a Bernoulli distribution? It's very similar to what we did before. Okay. Okay. Any other questions on this process? No? Any other comments on what we just did? Everyone's clear? Okay, so there are, yeah, okay, fuck you, response now. Okay, so there are some questions that you can go over here and see where you can get the answers from. Okay, all these points right there. And I am gonna stop recording and stop sharing.